Hey everybody, Dr. A here, and in this video we're going to be exploring another example of computing the centroid of a composite area. Now actually this is a remake of a video that I made 2 nights ago, and one of my students actually found a mistake in the previous version of this video, so shout out to Eli for catching a mistake I made, and so I've taken down that previous video and reposting this video as a correction video, but I want us to work through this, and I actually am going to point out the mistake I made in the previous version of this video to really help us all be very careful and just notice that even me as a professor sometimes makes mistakes. So you got to catch that mistake and you want to avoid these mistakes moving forward. So let's go ahead and get started. In the given information, we're being asked to compute the coordinates of the centroid, and we have this trapezoid shape right here. Now it's a composite area because it's made of two simple shapes, a rectangle and a triangle. And so whenever you have a composite area, it's the most convenient to separate the composite area into its two simpler shapes. So as you can see here, I'm breaking this trapezoid down to a rectangle shape that has a base length of 10 inches and a height of 8 inches, and a triangular shape here which has a base length of 5 inches and a height of 8 inches as well. Okay, let me fix this dimension line. And if you notice, I have an origin in the bottom left corner. This is the origin for the whole shape, and sometimes we call our reference axes that define the overall origin as our datum. So we can say this is our x datum and this is our y datum. So let's go ahead and get started. To generally formulate the coordinates of a centroid, we have x bar and we have y bar. And these are general formulas already presented here. So we have the summation as I goes from 1 to n x sub I times a sub I, all divided by the summation as I goes from 1 to n of a sub I. So this denominator is the total area of our shape. And then similarly, y bar gives us the summation as little I goes from 1 to n, y sub I, a sub I, again divided by a total area. So these are our governing equations. And for this particular shape, we can expand this to being x1, a1 plus x2, a2 divided by a1 plus a2. And then similarly for y bar, we'll have y1, a1 plus y2, a2, all divided by a1 plus a2, okay? Now, what we need to find is all of these components. Now, the areas A1 and A2 are going to come from the two different smaller, simpler shapes. So I'm going to call the rectangle part 1 or shape 1, and I'm going to call the triangle part 2 or shape 2, okay? So let's go to do that. If I scroll on down, I can see some of what I already calculated. Area 1, again, that's the rectangle. That's 10 inches by 8 inches, so that's 80 square inches. And then area 2 is the area of the triangle, 1/2 base times height. So 1/2 times 5 times 8 is 20 square inches. So that's all fine. Now let's talk about these values of x1, x2, y1, and y2, okay? That's what we really need to find, and I'll go ahead and tell you a little secret. The previous video, this is where I made a mistake, okay? So let's start with shape 1. Let's look at shape 1, okay? Shape 1 has an x coordinate that is right in the middle of itself, referenced from this origin here. So x1 is going to be this distance right here. This is x1. And for a rectangle, its centroidal coordinates for itself are right in the middle. So x1 is going to be 5 inches. That's going to be half of its base width, okay? And then similarly, y1 is going to be half of its height. So y1 is going to be 4 inches. So looking at shape 1, I already wrote that here. X1 is 5 inches, Y1 is 4 inches, no problem. Now, the mistake I made in my previous video was determining X2, okay? Now, for X2 is going to be measured from the origin to the centroid of part 2. So it's going to be measured somewhere about right here, okay? Now, here's where you got to be careful. It's a triangle. So a triangle by itself is going to have its own centroid that is going to be 1/3 of the dimension away from the back face. So this little dimension right here is going to be equal to 1/3 of 5 inches, which is just, let's punch that in our calculators, 1/3 of 5 inches. That should just be 1.667 inches, okay? But that's not X2, okay? That is the distance from this back face to the centroid of the triangle in the X direction. That's not really X2. In order to get X2, you have to add this full 10 inches to it, because again, X2 is measured from our origin over to the X coordinate of that triangle. So X2 is actually going to be 11.67 inches. So I'm going to come down here, and you see where I made my mistake earlier. I only counted it as 1.667 inches. In reality, what I should have written is 11.667 inches. It's got to have that 10 inches here built into it, because again, X2 is all of these X values and Y values are measured back to your overall origin. So make sure you, if you watched this video before and you already took notes on it, make sure you make that correction in your notes. X2 is in fact 11.667 inches. Okay, I'll write it here for us again. All right, now what about Y2? What about Y2? Well, Y2 is measured from the origin to the centroid of the triangular part in the vertical direction. So Y2 is right here. This was not a mistake in the previous video, so that's going to be 1/3 of 8 inches, which I believe comes out to be 2.667 inches, okay? So this 2.667 inches is correct for Y2. Now what we're going to do is we're going to substitute these values into our X bar and Y bar equation. So where are we going to need to make a correction here from my mistake in my previous videos? Well, this 1.667 should be 11.667 inches, okay? Everything else is correct. So just as a recap, we say X1 times A1, right? That comes from this term. So that's 5 inches times 80 square inches plus X2, that's the correction from the last video, times A2, and then divided by the total area, A1 plus A2. So when we punch this through in our calculators, we get an X bar value, not 4.33 inches, but it's actually 6.333 inches, okay? Now, what about Y bar? Well, Y bar was correct in the last video, but just as a recap, it's Y1 times A1, so that's 4 inches times 80 square inches, plus Y2 times A2, again, that's the 2.667 inches times 20 square inches, all divided by A1 plus A2, so we get to 3.733, and just to double check myself, I'll punch that in my calculator right now while we're recording the video. Times 20 divided by 100, and I do in fact get 3.733 inches. And so if I redraw a figure here to kind of summarize my findings, I'm going to say that here is my X bar and here is my Y bar, so it's about right here. And again, those coordinates are 6.333 inches, comma, 3.733 inches. Okay, that's my centroidal coordinates. And if you notice, this point right here, this centroid, is below 4 inches, which makes sense. Notice you have more area down here at the bottom compared to up here at the top, since you're missing a little slice right here. And notice X bar being 6.33 inches. It is a little bit closer to the origin than the halfway point of this entire base. This entire base is 15 inches long, so that means that the halfway point of the entire base is 7.5 inches. Notice that 6.33 inches is less than 7.5 inches. So I'll make a little note here just for our reference. Notice that X bar being 6.333 inches is less than 7.5 inches, and Y bar is 3.733 inches, which is less than 4 inches. I just like to note that because, again, it is what we expect. We expect X bar and Y bar to be less than the halfway measurements of the particular dimensions of this shape, since, again, it's a trapezoid. So notice there's more area down here at the bottom than there is at the top. So if you think of your centroid calculations as weighted averages, the centroid or that weighted average is closer to the origin than the halfway points of the 8 inches and the 15 inches. So that's just a way to kind of do a mental check as you're doing your calculations. Again, shout out to my student Eli for catching that numerical mistake here. And let's use this as a learning opportunity for all of us to be very careful when we're measuring our distances from that origin or from your datum. Thanks for watching. If this was a helpful video to you, please hit like and subscribe.